Audio Jungle.
Welcome to Maths TV. This is step-by-step revision series and we are going through differentiation. This is differentiation part 2. Part 1 hopefully you have seen. If you have not yet gone through part 1, better to go through part 1 and then you can watch this video. So in this video we will be going through maximum point, minimum point and some uses of differentiation. There will be part 3 in which you will be going through uses of differentiation. In part 1 we have covered how we are differentiating a given curve or expression. If it is given, how we can differentiate that one, how we can find the gradient of the curve by using differentiation. This is what we have covered in part 1. Now we will be covering maximum point and the minimum point in this video. So maximum point is a point at which the gradient is changing from positive to 0 to negative. So if we see the curve is like this one and gradient on this point is positive, this arrow is representing positive gradient, and this is horizontal line which is touching the curve at this point, so gradient is 0 over here, and gradient is negative on this side. So from positive to 0 and then negative. This point is known as maximum point, whereas minimum point is a minimum point. The gradient changes from negative to 0 and positive. So it will be, curve will be opening upward like this. So this side will be having negative gradient, this one, and this is having 0 gradient at this one, horizontal 0 gradient, and this side is having positive gradient. So arrow which is touching the curve to this side is having right side upward, so it is positive gradient. Now how we can use this one, how we can find these maximum point and minimum point. For this one we have selected some questions and we will be solving those questions and finding the maximum point and the minimum point. These are the two questions which we have selected for practice. Find the coordinates of the minimum point of the graphs. So these are the graphs given. Question number 1 we will tackle first. So what we will do, we will find dy by dx. So dy by dx will be equal to derivative of this one we know is 2x minus 6. So for the minimum point we know that gradient will be 0, so dy by dx we will put equal to 0. So it means 2x minus 6 is equal to 0 and 2x will be equal to 6. This implies x is equal to 6 by 2, which is equal to 3. Now we got this value 3. We will replace this value of x in this equation, and the equation is y is equal to x square minus 6x plus 11, and this value we can replace in this equation. This will be 3 squared minus 6 into 3 plus 11, and this will be 9 minus 18 plus 11, and this will be equal to 9 minus 18 plus 11 will be equal to 2. So we can write here 2. So our point will be x value first. So we can write the point. So I will move a little over here. So x value will be 3 and y value will be 2. So this value which 2 we found by like manually, we can use this method. We can use this calculator to solve this. Like for example, if I type this x squared, so alpha and x squared minus 6 and alpha x and plus 11, and then we can just press this calculate. For x is equal to 3. So if we replace x is equal to 3, we will get this 2. So this is how we can directly replace and calculate this value 2 as well. So I have shown you by calculator usage how we can reach to this 2 value, and manually also we can calculate, and the minimum point will be 3 and 2. So we can solve this question as well, which is y is equal to x square minus 2x plus 5. So dy by dx, again we'll take derivative. This will be equal to 2x minus 2. So this will be equal to 0 for the minimum point, and this will be 2x minus 2 is equal to 0. This implies 2x is equal to 2, x is equal to 1. Now this value we can replace in this, which is y is equal to 1 squared minus 2 into 1 plus 5. So this will be equal to 1 minus 2 plus 5, which is equal to 6 minus 2, which is 4. So we got this x as 1 and y as 4. Similarly, we can use calculator for this y value also. So we'll type this x square. So alpha, this one, x square minus 2 and this one plus 5, and calculate for x is equal to 1. So 1 will be 4. So this is how we can double check also that whatever we have calculated is correct. So depending upon the marks of the question, you can use calculator, or if you want to show your working, you can use manually also. But additionally, you can check, double check your answer during examination that whatever you have done is correct. This is question number 3, which we have chosen for our practice. Find the coordinates of the turning point. Coordinates of the turning point of the curve. This is the curve given. And additionally, they are saying identify the type of turning points. So this is also important. So first we will deal with this first section. We have done previously question 1 and 2, in which we know how to find the turning points. We will be taking the equation which is y is equal to 6 over x squared plus 12x. So this is our equation. We will be just changing this shape of this equation. Y is equal to 6x raised to the minus 2. So we have changed denominator into numerator, and then plus 12x. After this, we will differentiate dy over dx is equal to 6 as it is, and this power we will pull first. So this will be minus 2 in brackets, and x raised to power minus 2 minus 1, and plus 12x, derivative of 12x will be 12. And this is how we have taken this differentiation. And then we will put dy by dx is equal to 0. We know for turning points we are putting dy by dx is equal to 0. First order derivative we are putting equal to 0. So this will be, now we will start from here. 6 into minus 2 will be minus 12. So minus 12, x raised to a minus 3, minus 2 minus 1 will be minus 3, plus 12 is equal to 0. Next we have to find the value of x, and value of x, how we can find? We can shift this minus side to other side. So it will be 12x raised to a minus 3 is equal to 12. So x raised to a minus 3 is equal to 12 divided by 12, which is equal to 1. Now I'll have to move page a little above. So okay, now you can see properly. This will be x raised to minus 3 is equal to 1, or we can write 1 over x cube is equal to 1. So this implies x cube is equal to 1, and this implies x is equal to 1. So x is equal to 1. We will find the y value by putting this x is equal to 1 in this given equation, which is this one. So we can use calculator to find the value, or we can replace. So manually we can calculate y is equal to 6 over x cube plus 12x. So this will be equal to 6 over 1 cube plus 12 into 1. So this will be 6 plus 12, which is equal to 18. So y value will be equal to 18. So our point will be 1 and 18. Now we got the point. Part first of the question, first section of the question we have solved, which is asking find the coordinates of the turning point of the curve. So up to this one we have done, and the coordinates are here 1 and 18. Now the second line, which is saying and identify the type of turning points. This one we have to identify, and for this one I will be showing this on the graph paper. So this is the graph paper which I will be placing here. So this is the equation which you can see. I will copy this equation. Y is equal to 6 over x square plus 12x, and the point which we got, if you can see, this is the point 1 and 18. So 1 and 18 I will write here. So 1 and 18 is the point which we got, coordinates of that point. Now what we have to do, we have to check the type of this point, identify the type of the turning point. So for that one, for example, say consider this point. Okay, this point is say 1 and 18. 1 and 18 is, for example, this point. Now to check whether it is maximum or minimum point, we will use calculator. So how we will use calculator? I will type this equation. So I will write 6 over x square, so alpha x, this one, and squared, and plus 12 and x, so alpha, this one. So I have written this equation. Now if we replace 1, we will be getting 18, and we know to double check we can calculate for 1, this will be giving us 18. So you can see this is 1 and 18. Now what we will do, we will, x value is 1 over here. So on left hand side, on this side, we will take a little lesser value than 1. We can take 0.5 for example, or we can take 0.9, 0.8. All these values are lesser than 1. So we will be taking lesser than 1 value, which will be on this side. So I will be taking 0.5 value. So I will press calculate. This equation we have already written. So calculate for which x value? 0.5. So the value which we got is 30. So y value will be 30. So if we take x value as 0.5, we are getting y value as 30. Now this is what we got on this side. On this side we got this. Now on this side, right side, what we can do, we can take a little more than 1. So like for example 1.5. So calculate for which value? 1.5. So if we take 1.5 as x value, we will get 20.66. So x value, if we are taking 1.5, y value is coming as 20.67. So this is on the right side. So this is done. Now we can check. If we are taking one value, x is equal to 1, we are getting y value as 18. If we are moving to this side, we are taking 0.5, we are getting 30, which is more than 18. And if you check this value on this right side is also more than 18, which is 20.67. So these two values are showing that this side is going up and this side is also going up, because y value this one and this one both are more than 18. So both sides are upward. So this is, it means gradient on this side is negative and gradient on this side is positive, and this will be horizontal line, so zero gradient. So this is the minimum point. In this case, this will be minimum point, and minimum point is this one, 1 and 18. So answer which I have explained you on graph, we can write here this one as minimum. I'll show you hopefully here, over here. This is minimum point, which is 1 and 18. So this is basically the type of turning point which we have identified on this graph paper. You can see again, we can take this value, then a little lesser to this side, a little more to this side, then x value, and we are calculating y values. And I've shown you the easier method by using calculator, how you can calculate easily these two sides, and then we can identify on this basis whether it is maximum or a minimum point. So in this video we have covered maximum and minimum points, and I have tried to explain it in detail. Hopefully you understood everything. This was part 2. So remaining section will be covering in part 3, and don't forget to subscribe Maths TV and also like the video. Recommend this channel to your friends and also introduce this to your respective teachers. Thank you very much for watching. Take care. Bye.